Hello children, welcome to Zero Panic Maths. In today's session, let us continue our discussion on the exercise set 3.5. So before you come to the problems of this, please watch the previous video, because in the previous session we have discussed the different kinds of the different cases of identifying the rational decimals and irrational decimals, and even how to represent the given rationals into the form of P by Q rationals. All that concepts we have discussed in the previous session. Okay, so this is the continuation of the previous session, so you need the knowledge of the previous session to understand the exercise set 3.5. Okay, so let us continue solving the problems in exercise set 3.5. Okay, so this is also a very simple problem wherein we are asked to represent these rationals 7 by 20, 4 by 15 and 13 by 250 in the form of the decimals, and identify whether those decimals are terminating or they will be repeating, because these are the two important characteristics of the rational numbers. Okay, let us read the problem first. Without performing the long division, they are saying without performing the long division, that means without dividing 7 by 20, 4 by 15 and so on, we have to determine which of the following rational numbers will have the terminating decimals, okay, and then which will be having the repeating decimals. First of all, we need to do these three values or three rationals into the decimal format and decide whether they are terminating or repeating or they are irrationals. That we need to divide. That is the first part. Second part, after doing that, check your answers by explicitly doing the long division process, okay, and then rational numbers as decimals. So long division process is also the second part of this question. Understood this? Let us consider 7 by 20. Okay, so 7 by 20, we are not allowed to do the long division process. We will do that later. So this 20 should be represented in the form of prime factorization, the product of primes. Okay, so 4 5 is 24. I can write it as 2 to the power of 2 and 5. This is what is called as prime factorization. Okay, you know that. So 4 5 it is 20, and this is 7 by 4 5. So now multiply and divide the numerator and denominator here by 5, just to convert the denominator into 100. That is what we are doing. Such an example we have discussed in the previous session. That's why I'm not explaining it more. So 5 will get cancelled and this will remain as 7 by 20 only. But now with this multiplication and division by 5 will make the denominator as 100 and it is 35. Since it is 100 in the denominator, 2 digits of 35 will go after the decimal and this will become 0.35, and this is a terminating. So what kind of a decimal it is? It is a terminating decimal because we have exactly 2 digits after the decimal. This is 0.35. So you can write this as 7 by 20 is equal to 0.35, and also it is terminating. You can write that also as a terminating decimal. This is a rational decimal with terminating property. Hope you understood this. This is a very simple problem. Now coming to 4 by 15. Here also you need not do the long division process, but you need to convert that back to termination. But the process that we followed in the first problem is we try to convert the denominator into the multiples of 10 or 100 for specific reasons. Okay, but I cannot convert 15 into 100. But what I can do is I'll just convert this as 2 by 3 multiplied by 2 by 5. So can I do this way? Okay, it is 2 into 2 4 and 3 5s are 15. Okay, so 2 by 3, as we know already that 2 by 3 is, see, 0 point. When you say 0 point, why did I converted this? Because division will be easy for me. Okay, it is not a long division, but a simple division will give me the results here. Okay, so 0, when you say 0, it will become 20, and 3 6 it is 18. So 2 remains. Again it will become 20, and 3 6 3 6 so it will, this will go on, and that should be written as 0.6 bar. You know that. Okay, if there are digits repeating after the decimal point, that can be represented as a repeating digit with a bar on that. That is the reason I converted this into 2 by 3. Now, and what is this? This is, what is the second number? It is 0 point. When you say 0 point, it will become 20, and 5 fours it is 0.4. It is a repeating decimal, repeating rational, and it is a terminating rational. So I just converted that into two different values, and it will give me 0.4 multiplication. So when you multiply this 0.666666 and 0.4, this will actually give you 0.2 and 6. It is 6 fours are 24, something like that. But when you multiply actually the 6 digits after the decimal with 0.4, it will give you 0.26666 for infinite number of times. So that actually is 0.26. And what kind of a decimal it is? It is a repeating decimal, because though there is a fixed digit after the decimal, there is one digit that is actually getting repeated. So 4 by 15 is 0.26 bar, and it is repeating. This is the answer that you need to write. Hope you understood this also. Okay, so without long division only, we are trying to represent these. Okay, now let us consider the third one, that is 13 by 250. Okay, let me write 13 by 250 into three different values. 13 multiplied by 1 by 25 multiplied by 1 by 10. See, what did I wrote is 13 in the numerator, I just separated as a separate value, and 1 by 25 and 1 by 10 will actually make me 1 by 250. 250 in the denominator. I divided into 25 and 10. Why did I do that? Because you will be it will be easy for you to divide this 1 by 25. 1 by 25 will be 0 point. When you give 0 point, it will become 10, but still 10 is less than 25, so you will give a 0 here and take a 0 here. That will make 100 by 25, and is 25 fours are 100. So it will be easy for me to divide to 1 by 25 instead of 13 by 25. Hope you understood this. Okay, similarly 1 by 10 is 0.1. First you multiply 13 with 0.04. 13 fours are, it is 52, so it will be 0.52. 0.52 multiplied by 0.1. And you know that 0.1 is nothing but dividing by 10. When you divide this decimal by 10, this 5 digit will be pushed one digit to the right side, and it will always give you 0 inside that. Okay, so another 0 I'm inserting, because this 0 will be pushed to the right side. That way it is. Okay, so 13 by 250 is exactly 0.052, and it is terminating. We have to identify what kind of a decimal it is. So that's the reason we did this. Let us check the long division process. First value is dividing 20. Okay, sorry, dividing 7 by 20. 7 by 20, right? So it is 7 is the dividend here. Okay, and 20 is the divisor. 20 is the divisor. How do we get 7 by 20 at 0.35? By long division process. That is what we have to see here. Okay, now as you can see, 7 is less than 20. It cannot be divided by 20. So we will give 0 point. When we give 0 point, a 0, an extra 0 we will get. Okay, so 20 threes is 60. Now it is 70. I can divide it by 20, right? So 20 threes it is 60, and now I'm left with 10. Again, 10 is not divisible by 20. So, but since I have taken a decimal point here, I can just borrow one extra zero I can borrow, only one extra zero you should be borrowing. Okay, so now it is 100. I can directly divide 100 by 20 by 5. Okay, it is 100, and when I get a remainder as 0, I should stop dividing. Okay, so therefore it is 7 by 20. So I actually started with a division of 7 by 20, and what exactly I got is 0.35. This is how I verified this answer 7 by 20 as 0.35 by long division process. You understood this, right? Okay, so let us consider the second one. Second one is 4 by 15. Okay, so here 4 is the dividend and 15 is the divisor. Again, obviously 4 is not divisible by 15, so I will take 0 point. So when I take 0 point as 0, I will get an extra 0 borrowed here. So 15 3s are 45, so 15 3s I cannot do, 15 2s I can do, which is 30, and it is left with 10. Okay, so since again 10 is less than 15, I can borrow 1 0. I can just borrow 1 0 because of this decimal. 15 6 is 90, right? So another 10 I am left with. So 10, since it is not divisible, I can borrow a 0. Another 6, it will give me 15 6 90, 10, and this process continues, giving a borrowing a 0 and dividing it by 6 and 90. So this way this process continues, and it will give me 0.2 and 6 digit is repeated, and what is that value is 4 by 15 is equal to 0.2 fixed and 6 repeated. So this is how I confirmed this by long division process. You understood this, right? So this is how I did it without long division process, but this value I'm verifying it by the long division process. Hope you're getting it. Okay, so the third one is 13 by 250. I think 13 by 250. Let us do it with the long division process. It is 13 is the dividend now, and 250 is the divisor. 250 is the divisor. Now listen to me this carefully. Okay, so since 13 is less than 250, I can give 0 point and borrow a 0 here. When I give a decimal point, I can get a 0 borrowed, but still 130 is less than 250, so I can give a 0 here in the quotient and then borrow a 0. You understood the process? Okay, so when you give a decimal point, only 1 0 is allowed to borrow, but if you want another 0 here in the dividend, then you have to give a 0 in the quotient. That is what the process of long division is. Now 1300 is obviously greater than 250, then now you can divide this by 250. So 250 4s is 1000 and 250 5s 250 5 is 1250, right? So among 1300 I can deduct 1250. So what I am remained with is 50 only. Okay, 1300 minus 250 is 50. Sorry, 1250 is 50. Again 50 is less than 250, but since I have given a decimal point, I am allowed to take 1 0. Okay, without giving a 0 here, I am allowed to take 1 0. You can take. So 500 is twice than 250, so I can take 250 is 500 exactly, leaving me with a remainder as 0. So as I already told, when you reach the remainder as 0, you stop, and the quotient value is the exact value of what is the decimal that you want to get. So 13 by 250 is equal to 0.052, and this is a terminating decimal, terminating rational or decimal you can call. So that is also exactly equal to what we got by without performing a long division, 0.052. Hope you understood this. Okay, so this is a simple example of converting the rational decimals or identifying the rationals and irrationals and representing them by using different process, long division process and without long division. The second problem is a little bit different from the first one, that we are actually doing the long division process here to identify the decimal representation, and then confirming whether the performing the same long division process with numerator values, the different numerator values will give a different result. Okay, let us read the problem. Perform the long division of 1 by 13. Okay, obviously 1 by 13 is going to give us the repeating decimals, because 13 is a prime number. Okay, now identify the repeating blocks, a block of digits. Okay, so I'll let you know what is the repeating block of digits after performing the long division of 1 by 13. So let us, this is the first part that we are performing the division of 1 by 13 and identifying the repeating digits. Okay, then finally, second part is, does it show the cyclic properties if you evaluate 2 by 13? After performing 1 by 13, we will perform 2 by 13, or else we can multiply the given 1 by 13 value by 2, that will give us 2 by 13, and identify whether the result of 2 by 13 has the cyclic property. I'll let you know what is cyclic properties. Okay, so that is the second part of this question. Third part of this question is computing 3 by 13 and 4 by 13. 3 by 13 and 4 by 13 are actually the multiplication with 3 and 4 to this value only. Okay, I'll let you know that also. And what do you notice? Finally, after computing the values of 3 by 13 and 4 by 13, what kind of properties they possess in comparison to the value of 1 by 13? That is what the question is. So there are three different parts of this question. First of all, we need to perform the long division process of 1 by 13. Let us do that quickly. Okay, so let me take the value here. This is 1, okay, and 13. Okay, listen to me carefully. Okay, so since 1 is less than 13, I'll take 0 point. That will give me 1 0, but still 10 is less than 13, so I'll give a 0 here in the quotient and borrow a 0 here. Now it became 100, which is divisible by 13. Okay, not exactly, but which is greater than 13, I can say. So 13 sevens are 13 sevens are is 91, and what remained is 9 with me. Okay, so 100 minus 91, it is 9. So still I've given a 0 point here, so I can borrow 1 0. It is 90 now. 13 6 is 78. 13 6 is 78, and I'm left with 12. And since 12 is less than 13, I can still borrow a 0 here. Okay, now it is 120, and 13 9s is 117. Okay, so I'm left with 0, left with 3 here. I can borrow a 0 to make it 3, 30, which is greater than 13. 13 2s is 26. Okay, listen to me carefully. 13 2 is 26, and 30 minus 26, I'm left with 4. I can still borrow a 0 as usual, because I've given a decimal point here. Now it is 14, and 13 3s is 39. So I'm left with 1. I'm left with 1. 1 with 1, I can borrow a 0. Okay, but 10 is less than 13 again. So to make 10 divisible by 13, I have to borrow one more 0, but I have already borrowed the default 0 here. So to borrow a 0 here to make it 100, I'll have to borrow a 0 again here in the quotient. You understood this point? This step is very important. Okay, now it became 100, and it came to the very first stage only. Now if it is 100, I'll have to again multiply 13 by 7. Okay, so it will give me 7 here. 13 sevens are, it is 91. I am left with 9, and I will borrow 0. Okay, and that will make 90, and 90 is again as usual divided by 13 6 78, and I'm left with 12, and 12 will be 120, and 120 is divisible by 13 9s are 117, and this process will continue to repeat the digits that are previously there here. You can see that these are the digits. 0.07 here also, from here If you see that 0, 7, 6, 9, 6, 9 and 2, 3. You understood this? So therefore you can say 1 by 13 is actually given you the pattern as repeating pattern as 0.0769076923. How many digits are there? 6 digits. And from here onwards again 0769, you see that 6923, and this is the repeating one. So now you see what is cyclic property. So I will just first compute 2 by 13. 2 by 13. So 2 by 13, can I write it as 2 multiplied by 1 by 13? Because I know the value of 1 by 13 already. I don't have to perform this long division again. Okay, so I can directly put in the value of 1 by 13 here to make it 2 multiplied by 1 by 13. 1 by 13 it has 0 0.076923, correct? 0.76923. Okay, now multiply. This is actually repeating. This pattern is actually going to be repeating, but you can just multiply this two to the 6 digits and get the actual value. What is the actual value? It is 2 3s are 6, 2 3s are is 6, and 2 2s are 4. Okay, 2 9s are 18, 18. You will get 1 carry here. 2 9s are 18. Sorry, 2 9s are is 18, and 2 6s are 12, and 13, 1 carry 3 here. Okay, 2 7s are 14, and 15, 1 carry here. Okay, and 2 zeros are 0 and 1. It is 0.153846. Okay, so this is 2 by 13. Now what you need to identify here is, just listen to me carefully, what you need to identify here is, does this value 2 by 13 possesses a cyclic property? Cyclic property means the value that you get after multiplying this 0.076923 by 2, are you getting a value which is actually created by shifting these digits only? Okay, 0 7 6 9 2 3, these numbers only are repeating here in the result. Okay, no, see, you see that these are totally different digits only, 0.076923, and this is different 153846, some different numbers are only you are getting. So this 2 by 13 does not possess a cyclic property with 1 by 13. That is what the answer to the second question. Does it show the cyclic property? No, it does not show the cyclic property with 1 by 13. Okay, now you will come to know what exactly is cyclic property, because when you calculate this 3 by 13 and 4 by 13, you are going to get the result as cyclic properties only. Okay, you will come to know that, but let us first write the answer to this. No. Okay, no, 2 by 13 does not 1 by 13, or whatever way you want to answer, you can answer it. Okay, so this is the second part. Now the third part, now we have to compute 3 by 13 and 4 by 13 in the similar way. Okay, you have to just say 3 multiplied by 1 by 13 and 4 multiplied by 1 by 13, because we have already evaluated 1 by 13 value, and identify whether they possess the cyclic property or not. Okay, let us go to the next slide to do that. Okay, now let me write what is 3 by 13. Okay, so what is 3 by 13 is 3 multiplied by 1 by 13, and we know the result value of 1 by 13 already. So let me write it as 3 multiplied by 0.076923, correct? So this is the value, right? This is the value we already got as 1 by 13. Now multiply this with 3. Okay, so that will give me 3 3s are 9. It is 0.230769 is the value of this. Now you see the cyclic property. Now you will come to know what exactly is cyclic property. Now if you observe the value of 3 by 13, which is 230769, it is actually created, or it is actually evaluated by shifting the value of 1 by 13 only. You see that 2 3 are the first two digits that appear here. Okay, and thereafter if you come back and see the digits of the remaining digits of this, it is 0769. See, 0769. So it means that 23 is shifted to the front and it became 230769. It is how cyclic property. You are cyclically shifting the digits one after the other to get the value of the next one. You understood this, right? So 3 by 13 possess a cyclic property with 1 by 13. Okay, now let us calculate 4 by 13 also and see whether it also has that same cyclic property or not. So 4 by 13, I will write it as 4 multiplied by 1 by 13, and I'll take it as 4 multiplied by 0.076923. Okay, so it is 1 by 13. Okay, now multiply 4 to all these digits. Okay, let me multiply. Okay, now just observe this value 307692. You see that 3, the last digit. Okay, it is coming when you shift 3 to the beginning, it is becoming 307. See, here also these digits are getting repeated here. You see that 07692, 07692. You are just pushing this 3 to the beginning. Okay, that is what is cyclic property. So again you observe that 3 by 13 and 4 by 13 both possess the cyclic property, and that is what is required here. That is what they are asking. After computing 3 by 13 and 4 by 13, what do you notice? We notice that 3 by 13 and 4 by 13 possess a cyclic property with 1 by 13, unlike 2 by 13. 2 by 13 does not do that, but 3 by 13 and 4 by 13 have a cyclic property. Hope you understood this. Okay, so finally you can write that we observe, therefore we observe or we notice that with 1 by 13. So this is the answer to the second question. You understood this? So all the three parts of second question we resolved it. Okay, now the third question is classify the following numbers as rational or irrational. We need to identify whether they are rational or irrational. You know the definition of rational: anything that can be represented in the form of p by q, where p and q are integers and q not equal to 0 is rational. Okay, and anything which is not in the form of rational is irrational. Okay, now what is 81? 81 is rational. We know that 81 is rational. Simple, because 81 can be written as a p by q format. 81 by 1, where 81 is an integer, q p denominator 1 is also an integer, and 1 not equal to 0, q not equal to 0. Now why I am writing this? Because after giving all the 6 problems here, they are asking find the explicit fractions in case they are rational. Okay, so they are asking us to find out the fractions, or they are asking us to represent it in the form of p by q. So 81, I am representing it in the form of 81 by 1. Okay, last part. Second, 12. 12 is also rational, and 12, since 12 I can write it as 12 divided by 1, which is in the form of p by q. Now this is also a rational only. 0.3333 is a rational only, but it is a repeating rational. Repeating rational, how to write a repeating rational in the form of p by q? How to write? We have done it in the previous session also, that consider this as 0.0. It is x is equal to 0.3 bar. Okay, and multiply this by 10. That process we need to continue. Okay, let me check whether I have the space to do that. Okay, let us do that for this third problem. Okay, let us park this third problem later calculation. Okay, but let us identify the fourth one. Okay, listen to me carefully here. Fourth one, it looks like an irrational number because it continues, but you observe carefully. 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. Okay, this pattern is actually getting repeated, so it is a repeating rational. Again, you can say that this is repeating rational, and where you can consider x is equal to 0.1 2 3 4 5, 1 2 3 4 5, like this. You understood? Okay. We need to convert these to 0.333 and 0.12345 rationals into the form of P by Q. I will let you know that. Okay. But before that, you need to identify the fifth one. Fifth one is an irrational number, because you see, it is first of all, it is uh, not repeating, and also not terminating. Also non-terminating, that looks here, but if you observe the pattern, there is no particular pattern that is getting repeated. You see that 0 0 0 1 0 0 0 1 0 0 0 1, so nothing is getting repeated, so this one you can write it as irrational. And for irrational, you need not write that into the form of P by Q, because it does not possess that property. Okay, so this is the answer for fifth one. Sixth one, it is a terminating rational. It is a rational only. Okay, to actually classifying it, it is a rational number only. Now let us do third and fourth questions. Third is third question is representing 0.3. It is repeated, and let us consider this as x. Okay, you know that how to convert this into P by Q format. That consider this as equation 1, and since one digit is repeating, since here one digit is repeating, you know that, right? Okay, in the previous class we have seen this. One digit is repeating, we have to multiply this by 10. Okay, multiply by 10, or 10 to the power of 1, multiply by 1, sorry, 10. Okay, and that will give us 10x is equal to, it is 0.333, so it will be 1 3 taking to the left side, and again right side it remains with 3 3 3 3, that continues. Okay, so it will be 3.30. Why it becomes like this, I've already told. Now equation 2, you subtract it from equation equation 1 from equation 2, that is equation 2 minus 1. This process we have already done it in the previous session. So 10x minus x is the left hand side value, and 3.3 bar minus 0.3 bar. So since it is minus, the decimals after the digits after the decimal point will actually cancel out, and it remains with 3 in the right hand side only, and here it is 9x, and x is equal to 3 by 9. Okay, okay, and that is x is equal to 1 by. So this is what the P by Q representation of 0.333. The second one is similar one. Second one is, you need to consider x is equal to 0.12345. 5 digits are repeating. Okay, so equation 1. Okay, and since 5 digits are repeating, you need to multiply this with how much? It is 10 to the power of 10 to the power of 5, multiply by 10 to the power of 5, that is 1 followed by 5 zeros, so that will give you 1 followed by 5 zeros. Okay, it is 1 lakh. Okay, x is equal to taking 1 2 3 4 5, because why I am multiplying 1 followed by 5 zeros, I want to take all these 5 digits to the right side, so it will give me 1 2 3 4 5 0.12345 bar. It is what my second equation is. Okay, I'm not going to resolve this because it is exactly the same steps you are going to perform. Again, equation 2 minus equation 1, it will actually give you this minus this x. It is actually going to give you 99,999, because it is 1 lakh x. It is 99,999x minus 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, no, I've already resolved it. Okay, so if you subtract this from this, the right side 1, 2, 3, 4, 5 bar will go on getting cancelled, and it is left with 1, 2, 3, 4, 5, and x is equal to 1, 2, 3, 4, 5 divided by 99,999. It is the representation of this 0.12345 in the form of p by q. If you can divide, if it divides by any common factor, you can divide it and keep a smaller fraction also. That is also fine. Okay, so this is the fourth one. This is the fourth one. You can verify the answers later. Okay, now as we have seen, fifth one is irrational, we don't have to resolve it, but sixth one we need to resolve it. Okay, I think sixth one I have already resolved. Okay, sixth one, just to save the time, because there are so many digits here, I've just already resolved it. I'll just explain you. Okay, let us consider this. We already know that this is a rational number only, because it is terminating. See, though there are not repeating any repeating pattern, you are not observing here, but it is terminated after some digits. And how many digits are there? Okay, since the digits are terminated, but how many digits are there? 21 digits after the decimal. If you count this, this will be 21 digits. So as many digits after the decimal point it can have, but it should be terminating, then it is a rational number only. It is a rational number only. If not terminating, it should have a repeating pattern in that. Okay, so it is terminating after 21 digits. So since I have 21 digits after the decimal point, if I have to bring all these to the left side, I have to multiply this by 10 to the power of 21. Sorry, divide it by 10 to the power of 21. You understood, right? So 10 to the power of 21 when I divide, and same thing I multiply here also. So it is like this, 10 to the power of 21 and divide 10 to the power of 21. Multiply and divide this. So this will bring 21 digits to the left side, and this will make this value. Okay, I cannot read this value, that big amount it is. So this is the value divided by 10 to the power of 21. See, one small step I am doing here. 10 to the power of 21, I am writing it as 10 to the power of 20 and multiplied by 10, because I just want to cancel this last 0 with this 0. So this will left with this value till 12, digits 12, and 10 to the power of 20, it is 1 followed by 20 zeros. This is the answer to the last question. So representing this terminating decimal into or rational into p by q format is this. Understood this? Okay, so if you want to resolve this, you have to do it in this way only. Okay, hope you understood this. Okay, let me see the next problem. Okay, the next problem is very interesting, but we have resolved such problems already. Okay, you see that the number 0.9 bar, 0.9 bar means 0.9999. I've told it so many times. Okay, which means this only. Okay, they already told it. Okay, is a rational number. We know that is a rational number. Using the algebra, let x is equal to 0.9. We have already know. Know that method of considering this as x and multiply by 10 and subtract. Explain why 0.9 bar is exactly equal to 1. We need to prove that 0.9 bar is exactly equal to 1. Okay, now let us consider that only. Listen to me carefully. X is equal to 0.9 bar. And 0.9 bar, as you know, it is 0.99999. Okay, consider this as equation 1. Okay, now we know that the process is, since there is only one digit is repeating after the decimal point, only one digit repeating. Since one digit is repeating, multiply by 10 to the power of 1, that is 10 only. Okay, multiply by 10 to the power of 1, that is equal to 10, because there is only one. So what I'm going to get is 10x, multiply this equation 1. Okay, 10x, as I already told, if you multiply this 10 with 0.999, 9 will be pushed to the left side, and again because there are infinite number of 9s in the right hand side, it again will be left with 9 bars. 9 bar, and consider this as equation 2. Okay, now subtract equation 1 from equation 2. Okay, equation 2 minus equation 1. So what it will give me? 10x minus x. Okay, so 10x minus x is equal to 9.9 bar minus 0.9 bar. It is the right side of the equation 1. So as I already told, 0.9 bar, 0.9 bar, this 9 bars after the decimal point will cancel from both these values, and I am left with 9.0 or 9 only here in the right hand side, and here also 10x minus x will give me 9x, and that is x is equal to 9 divided by 9, and therefore x is equal to 1. And this is the proof that 0.09 bar, sorry, 0.9 bar or 0.99999 is exactly equal to 1. This is how we proved. So finally you can write it like 0.9 bar is equal to 0.9999, continue, is equal to 1. This is the answer. Let us see the next problem. Okay, now the next problem is, okay, it is about again the cyclic procedure. Okay, cyclic property. We have seen that the repeating block of 1 by 7 is a cyclic number. Okay, so they have already told that 1 by 7 value is a cyclic number. Okay, cyclic number. Try to find more such numbers, n numbers. So considering 7 as n here, the reciprocal of that is 1 by 7. So they are saying try to find some more such numbers n whose reciprocal 1 by n, as it is 1 by 7 here, produce the decimals with repeating blocks that are cyclic. Repeating blocks that are cyclic. Okay, now try to understand here. They already told that 1 by 7 whose value is cyclic in number. Okay, let us consider, I've already written the solution here because I don't wanted to spend time on calculating 1 by 7 with a long division process. Okay, now we already know that 1 by 7, if you perform 1 by 7 with a long division process, you will have 1 by 7 as 0.142857, and this pattern repeating. So that's why I given bar here. Okay, understood this? Okay, now if you multiply 1 by 7 with 2, that is 2 by 7. 2 by 7 means, what is 2 by 7? It is 2 multiplied by the value of 1 by 7. Okay, so let us don't underline this because it will be confusing, because it is bar here. It is a bar in the upper side. It is 0.14287. That is the value of 1 by 7. I am multiplying it with 2 to get 2 by 7. And what is the value of that? What is the value of that? It is 285714. If you observe clearly here, it is 2857. See, 2857 in the beginning, and after that it is continued with 14 as a cyclic method. See, it is 14 coming from the beginning, or you can say it started with 2857 and goes in the cyclic process to get 14 as the second values. You getting my point? Similarly, if you calculate 3 by 7, that is multiplying 3 with 142857, that is the value of 1 by 7, you will get this value 428, and 428571 are again got by the cyclic procedure only. See, 428, see, 42857, and finally after 7 it is coming with 1 here. It is coming with 1 in the end. So this is that cyclic process. So they have already told that 1 by 7 is a cyclic number. So that is why we call it as a cyclic number, because it possesses that property with all its factors. Understood this? Okay. Now they are asking us to find some more n numbers. Now if you observe clearly, 1 by 7, 7 is a prime number. Let us consider that also as one of the important point, and consider only the prime numbers and the reciprocals of the prime numbers. What is the next prime number? 7 is a prime number. Okay, so the next two prime numbers 11 and 13 does not possess this cyclic property. Why I am saying this? Okay, next two prime numbers are 11 and 13, and if you consider 1 by 11, 1 by 11, what is 1 by 11? 0 point. If you give 0 point, it is 10 here, but it is not possible to divide 10 by 11 again, so I'll give a 0 here. That makes it 100. Okay, and 9, it remains with 1, again 9, so it is 0.09. But if you multiply this with 2 to get 2 by 11, but what is 2 by 11? 2 by 11 will be twice of this, and it will be 0.18 repeating. 0.1818 repeating. Does 0.18 is calculated or created by using shifting of the numbers of 1 by 11? No. So this does not possess the cyclic property. And same thing happens with 1 by 13 also, because we already did it in the very first problem itself. Okay, 1 by 13 does not have a cyclic property with 2 by 13. Already know that. With 3 by 13 and 4 by 13 it has, but it has to have that with all its numbers. So 2 by 13 does not possess a cyclic property. We already calculated it. Okay, if you want, you can write that value and say that 11 and 13 are the two next prime numbers after 7, but they does not possess the cyclic property. So what is the next prime number? Let us consider next prime number as 1 by 17. Okay, I'm again not doing this cyclic procedure, but 1 by the long division, 1 by 17, when you calculate, it will give you this as the repeating pattern. Okay, this as a repeating pattern. It is not a terminating one. This is a repeating pattern. You see that it is a repeating pattern, and after that these many digits will be repeating. Even for 1 by 19, because 19 is the next prime number. See, I'm considering only prime numbers. Okay, I'm trying to find this n, and the reciprocal of n, it is 1 by 17 and 19. This also has some digits, and after the digit the same digits will be repeating, has this property. So I have two more numbers, 1 by 17 and 1 by 19, and this is done by trial and error. Okay, so you need to do this and then see that these values are getting repeated. And with that also, 2 by 17 if you perform, then the value that you get, you are going to get, that is by adjusting cyclically these numbers only. Similarly, 1 by 19 also possess that. Okay, now after performing all this, what you will come to know is, see, note this, this is very important. Okay, listen to me carefully. They are saying, when does this happen? When does this happen? We are answering this. Okay, for a prime number p, listen to me carefully, for any general prime number p, the decimal expansion of 1 by p, that is reciprocal of p, has the maximum possible length as p minus 1. When it has p minus 1 length as the repeating pattern, then only it fits into that pattern. Okay, I'll give you an example of this. Okay, listen to me carefully. When it is 1 by 7, 7 is the prime number. Okay, you see how many digits are there here in the repeating pattern? 1 2 3 4 5 6 7. 6 are there. That is p minus 1. If p is the prime number, 7 is the prime number. Okay, and p minus 1, 7 minus 1, that is 6. 6 digits are there here. Only 6 digits are there here. Okay, with 1 by 11, how many digits are there? Only 2 digits. What is 1 by 13? 1 by 13 is some 6 digit value only. Okay, you can check it from the very first problem. 1 by 13 was also not having as many digits as 12 in the decimal part. Okay, it does not have that. So 1 by 11 and 1 by 13 does not have it. But 1 by 17, if you check, these digits are, there are 16 digits after the decimal point. which is 1 less than 17. If you consider it for 19 also, it is 18 digits that it has after the decimal points, and the same 18 digits are getting repeated after this pattern if you calculate it. You getting my point? Okay, so it means that in general, for a prime number p, listen to me carefully, for a prime number p, if the decimal expansion of 1 by p has the maximum possible length of p minus 1, then only this pattern fits in. That's why 1 by 11 and 1 by 13 does not fit into this pattern. Understood? Because 1 by 11 and 1 by 13 does not have that repeating pattern. Okay, make a note of this. Okay, now you can see that. Okay, you see in the very beginning they started with natural numbers 1 2 3 4, some positive numbers, and natural numbers along with 0 made whole numbers. And if you have the negative counterparts of these positive values, that will make it as an integer. See, the pictorially also, the yellow part is actually the superset of the pink part, which is natural numbers. You understood? Now the yellow part is made the child of the blue part, rational numbers, because rational numbers represented in the form of p by q, those might include negative integers, positive integers, but nowhere q is not equal to 0, that is a rational number. So this part is rational number. Now coming to irrational part, it is one set where it does not possess the property of p by q. Okay, but it can be represented in the non-repeating non-terminal values, and they can be negative and positive. These are the examples of irrational numbers. So this irrational number set, rational number set, makes the whole big set of real numbers. So this picture you should remember, so that you will come to know how did our world of numbers got evolved. Understood this? Okay, hope you can get a picture out of this. Okay, now let us see the end of chapters. Okay, now we have completed our session today with exercise set 3.5. Let us discuss this end of chapters in the next session. Okay, thank you.